In continuation with application of derivatives, let's have a look at another question where differential calculus is going to be helpful in understanding the number of roots of a polynomial. The question is the number of distinct real roots of the equation 3x power 4 plus 4x cube minus 12x square plus 4 is equal to 0. So we don't know how many roots it will have. We don't know how to factorize this. So let us use differential calculus here. Let us call f of x is equal to 3x power 4 plus 4x cube minus 12x square plus 4. Let us differentiate it. So f dash of x is equal to 12x cube plus 12x square minus 24x, which can be factorized as 12x can be pulled out. You have a x square plus x minus 2, which can be factorized as 12x into x plus 2 into x minus 1. This is our f dash of x. To find out the points of maxima minima, let us equate f dash of x to 0. We get three turning points, x is equal to 0, or x is equal to minus 2, or x is equal to 1. But we do not know whether these points are points of maxima or points of minima. So let us understand whether the curve is increasing to decreasing or decreasing to increasing. So let us plot minus 2, 0 and 1. Let us choose some value in this interval to the right of 1 and substitute here. Suppose you substituted 2 here in the place of x. This is positive, this is positive, this is positive. So in this zone, f dash is positive. Between 0 and 1, you can substitute half. This is positive, this is positive, this is negative. So the product will be negative. Between minus 2 and 0, you can substitute minus 1, negative, positive, negative. So the product f dashed is going to be positive. Here f dashed is negative. To the left, namely minus 2, minus infinity to minus 2, you can put minus 3, negative, negative, negative. So the product is negative. So what is our understanding? Our understanding is this function f of x decreases up to minus 2, then increases up to 0, then again decreases up to 1, then again increases up to infinity. So let us try to, so our points of concern are minus 2, 0 and 1. Let us try to sketch the graph roughly. So one point of concern is minus 2 and one point of concern is 0, one point of concern is 1. So what is how is it behaving? The function is decreasing up to minus 2. So at minus 2, let us find the value. If you put x is equal to minus 2, if you put x is equal to minus 2, y value is going to be 3 into 16, 48. So minus 2 means this is another minus 32. Then when you put x equal to minus 2, this is minus 48 plus 4. So I can get when x is equal to minus 2, the y value is minus 28. So you get minus 2 comma minus 28. So it is going to decrease like this. It is going to decrease up to minus 2. Then from minus 2 to 1, from minus 2 to 0, it is increasing. So I will just try to find out at x equal to 0, y value is equal to 4. So I don't know where it cuts. If you want, you can find out that also. When you put x equal to minus 1, maybe you put x is equal to minus 1, y will be 3 minus 4 minus 12 plus 4. So you can see it is minus 9. It is still negative. So I think that the other root should be between 0 and minus 1 and 0. It should be going up like this. So we know from minus 2 to 0 it is increasing. Look here, minus 2 to 0 it is increasing. 0 to 1 it is decreasing. So let us substitute x is equal to 1. If you put x is equal to 1, y value is going to be 3 plus 4 minus 12 plus 4, which is equal to minus 1. So at 1, the corresponding y value is minus 1. So between 0 and 1 there is going to be one root. From 1 to infinity it is again increasing. So I think x is equal to 2 should be sufficient for me. Let me find the y value. 3 into 16, that is 48, plus 8 fours are 32, minus 12 fours are 48 plus 4. You can see this is equal to 36. So at 2 the y value is 2 comma 30, some large number. The diagram is not to scale. The graph goes like this. It keeps on going upwards. So do you understand that this is increasing, decreasing, increasing and decreasing, and the corresponding y value here is negative, the corresponding y value is positive, the corresponding y value is negative. So if it is increasing, it is cutting the x-axis and going up to 0 comma 4, then cutting the x-axis and coming down, then again cutting the x-axis and going up. We can see that this graph crosses the x-axis 1, 2, 3, 4. So what is the answer to the question? The number of real roots. Number of real roots is equal to 4. This is slightly trickier in comparison to the previous question, where it was just one real root because the function was always a increasing function. And this is how we can use application of derivatives in understanding the number of roots of polynomial function of higher degrees.